Welcome to the deep dive.
Have you ever pictured an AI that doesn't just answer you, but actually thinks for itself?
Mm,
An AI, you could give a really big goal like research the electric vehicle market, and it would just go off and plan everything, do everything, tweak things along the way, all by itself.
right, without constant hand-holding.
Exactly. Well, that whole idea kind of exploded onto the scene in early 2023 with this open source thing called AutoGPT. It felt like a real glimpse into, maybe artificial general intelligence, AGI. It really shifted the conversation.
It absolutely did. It was a move away from just chatbots. This was suggesting AI could manage projects, maybe even course correct on its own.
So today we're going to, peel back the layers on that initial hype. We want to really unpack AutoGPT.
Okay.
Look at its architecture, how it tried to think, what it actually managed to do, and crucially, the big problems that stopped it from, taking over the world. Yeah, the reality check. Our goal here is to give you a really clear picture what AutoGPT was, what it meant for AI, and why it hasn't become this everyday tool many thought it might.
Right. We want you to get the core concepts, the surprising bits, and the big questions it raised, but without getting totally bogged down in tech speak.
Exactly.
So let's start with that core idea again. This AI taking a high-level goal, say, research EDs,
Yep.
and then figuring out all the steps, doing them, learning from them. That was the vision, right? Moving AI from just answering questions to actually managing projects independently.
And what was so interesting was that AutoGPT was one of the first times many people saw a large language model, specifically GPT-4 in many cases, doing tasks without a human prompting every single step.
Oh, okay.
It showed how maybe you could chain together these LLM thoughts to tackle complex goals. It really hinted at a future of, possibly autonomous AI agents.
So how did they actually build this thing? It sounds super ambitious.
It started pretty raw. The first version, AutoGPT Classic, was basically a Python application, mostly for developers.
Okay, so not exactly user-friendly at first.
Not at all. It was powerful, definitely. It could get into your local files, run code,
Right.
but that also made it, unpredictable. And setting it up, you needed to be comfortable with Python, Git, Docker, getting API keys. Quite a hurdle.
Yeah, sounds like it.
And that early version, that sort of wild, uncontrolled approach, it hit problems fast, difficult to install, like we said, super expensive sometimes because it just kept making API calls without much oversight.
Oh, right, the cost.
Yeah, huge cost potential. And frankly, potentially dangerous letting it run loose on your system, which raised this big question for everyone. If we want these agents to be more than just experiments, how do we build in safety and predictability?
And that led to something else.
It did. In response, we saw the AutoGPT platform emerge. This was, let's say, a more grown-up, commercially focused version. It split things up. A solid back-end server to handle the heavy lifting, manage the agent running, make it more reliable.
And the front end.
That was the big change for accessibility. A user-friendly interface, low code, with drag-and-drop canvas, you could actually see the workflow.
Ah, visual.
Exactly. So suddenly, people without deep coding skills could start building and managing these automated processes. The focus shifted a bit from pure autonomy to more like sophisticated workflow automation that a human oversees.
Okay, that makes sense. But underneath it all, what's the engine? What makes AutoGPT tick?
At its heart, it's still that large language model, often GPT-4, acting as the brain.
Right.
But the key difference is giving that brain tools to interact with the world outside its text-based environment.
Tools like what?
Well, fundamental things. The ability to search the web for up-to-date info, the ability to read and write local files, and crucially, the power to execute its own code, usually Python, to solve problems or even try to fix itself.
Okay.
And it was designed to be extendable, too. Developers could add new tools connected to other services through this component system.
In this platform you mentioned, it made managing these tools easier with agents and blocks. How did that work?
Yeah, exactly. They call them agents, but you can think of them more like workflows. And you build these workflows by connecting blocks.
So blocks are like pre-made functions.
Pretty much. Like a search the web block or an AI text generator block. You visually drag them onto a canvas, connect them up, and design these quite complex multi-step processes without actually writing lines and lines of code. It really lowered the barrier to entry.
Okay, so you give it a goal, it has tools, it has a workflow. How does it actually figure out the steps? It can't just be random guessing, right?
No, definitely not. It has this quite clever operational loop. It starts with planning. You give it the big goal.
Like the EV research.
Right. And conceptually, a task creation agent, or rather the LLM, prompted to act like one breaks that big goal down into smaller, manageable subtasks.
Okay, chunking it down.
Then, another part, the task prioritization agent figures out the logical order for those tasks, what needs to happen first.
Makes sense.
And then the task execution agent gets to work on the first task, using all those tools, the LLM brain, web search, maybe writing some code.
And does it learn from that step?
Sort of. The result of that task gets fed back into the system. That feedback helps it refine the plan, decide on the next step. It's this constant loop plan, execute, feedback, replan. That's really the core of how it tries to be autonomous.
You said conceptually these are different agents. What does that mean in practice?
Yeah, that's an important point. It's often described as these separate agents, but really, it's usually the same LLM instance talking to itself, just prompted to wear different hats, the planner hat, the executor hat.
Ah, okay, so it's like an internal dialogue.
Exactly.
Yeah.
Which is clever, but it's also a potential weakness. If the LLM's reasoning goes off track, there isn't really an independent boss agent to step in and say, hang on, that's wrong. That's where you can get into trouble.
And to help with that, to make the thinking more structured, there was this REACT framework. You mentioned it briefly.
Yes, REACT. It stands for reason and act. It's a really neat idea. Instead of just spitting out an answer, the AI is prompted to output its internal monologue.
Like showing its work.
Precisely. It outputs its thoughts, its reasoning for why it's choosing the next action, its plan, and even a criticism step where it tries to poke holes in its own plan before acting.
That sounds useful. Does it actually help?
Generally, yes. Forcing the LLM to articulate its steps like that tends to lead to more reliable results. It mimics how a person might deliberately think through a problem, allowing for a kind of self-correction loop.
Okay, but what about memory? LLMs famously have short memories, right? That context window limit.
Yeah.
How does AutoGPT keep track of a big project?
Good question. It uses a two-part system. For the immediate task, it relies on the LLM's short-term memory, its active context window, like a mental scratch pad. But for the long haul, to remember things across many steps, it connects to external vector databases. Things like Pinecone became popular.
Vector databases, how do they help?
So key bits of information from each cycle, what it did, what it found, get converted into these numerical representations called embeddings. Think of it like indexing by meaning, not just keywords. This gets stored in the database.
Right.
Then, when the agent is planning its next move, it can query this database, asking, what relevant stuff have I learned before? It pulls back the most similar past memories, giving it context it would have otherwise forgotten. That long-term recall is pretty fundamental to making it seem autonomous.
Okay, so we have the architecture, the thinking process, the memory. What actually happened when people let this loose on real tasks? Did it work?
Well, people certainly tried. It was used for market research, like you mentioned with the EVs, or finding, say, the top 5 waterproof headphones.
And could it do it?
It could, yeah. It would go search the web, scrape information, try to compare features, summarize things.
I remember seeing someone got it to generate a whole business plan for an EV startup. That seems pretty impressive.
It is impressive as a demo, for sure. But, and this is a big one, but the quality was totally dependent on what information it found online and how well the LLM could piece it together without making things up, hallucinating facts.
Ah, the hallucination problem.
Exactly. So you really had to treat its output as a starting point. You'd need a human to rigorously check everything, especially if you were making real decisions based on it.
Okay, fair enough. What about coding? Could it actually write software?
Surprisingly, yes, to a certain extent. People gave it goals like build me a simple weather app or make a basic website with React.
And it would.
It would try. It would plan the steps, write HTML, CSS, JavaScript code, maybe try to connect to weather APIs. There was one report of it building a functional, simple website in under 3 minutes.
Wow.
And maybe even more impressively, there was this one case where it realized Node.js wasn't installed on the system. So it autonomously searched Stack Overflow for how to install it, downloaded it, and then started the server it needed. That's pretty close to self-sufficiency.
That is wild. But did it work reliably for complex stuff?
Less so. It often got tangled up with more complex logic. It could easily get stuck in debugging loops, trying to fix errors it itself had created, or sometimes chasing phantom bugs.
Right.
And maybe more importantly, the security aspect. Letting an AI autonomously run code it writes or downloads, that's a huge risk. Everyone quickly realized you had to run it in a
A
sandbox.
sandbox, like isolating it.
Yeah, like using Docker containers or a dedicated virtual machine, something to wall it off so if it did something bad, it couldn't trash your main computer.
No.
Definitely not something to run unprotected.
Okay, so coding was possible, but tricky and risky. What about content creation? Blog posts, marketing?
Yep, people tried that too. There was an example where it researched and drafted a pretty long article, like 1,200 words, on digital nomadism. The user said the first draft was about 90% usable.
That's pretty good.
And there was a really interesting banking case study. An agent apparently drafted and A/B tested different email campaigns to attract bank deposits. It kept tweaking the interest rates in the emails until it supposedly raised over $2 million in deposits.
Whoa, okay. That's tangible impact.
For sure. For automating certain routine writing or testing tasks, it showed real promise. But again, the final output usually needed a human touch. It often lacked, nuance, maybe emotional intelligence, a unique voice.
So human review was always essential.
Always. You needed to check for factual accuracy, quality, tone, potential bias, making sure it didn't say something legally non-compliant. It was a powerful assistant, maybe, but not a replacement writer.
Okay, so it had these moments of brilliance, these impressive demos. But if it could do all that, why isn't AutoGPT running everything now? It feels like the hype died down. What went wrong?
Yeah, this is where the rubber really meets the road. Why do some cool tech demos fizzle out? For AutoGPT, the absolute biggest hurdle was cost.
Cost. Like, running it was expensive.
Incredibly so, potentially. Remember that loop. Plan, execute, feedback. Every single step, every thought it had, usually meant another API call to GPT-4 or whatever LLM it was using. And those calls add up fast.
How fast are we talking?
Well, people were reporting things like over $14 just for a relatively simple task that took maybe 50 steps using GPT-4. And often they'd spend that money and the task wouldn't even complete successfully.
Ouch. That's not sustainable for regular use.
Not at all. And there was a deeper problem with the cost model. It couldn't really learn efficiently. If it spent $14 figuring out how to generate, say, a Thanksgiving recipe,
Yeah.
it would likely cost another $14 to generate a Christmas recipe, even if the process was almost identical. It couldn't abstract the process and reuse it cheaply. Every task was like starting from scratch, cost-wise, fundamentally inefficient for anything repetitive.
Okay, so cost was killer. What else? You mentioned loops earlier getting stuck.
Yes, the dreaded infinite loops. That was incredibly frustrating for users. It would just repeat the same command over and over and over.
For was it just a bug?
It was deeper than a simple bug. It pointed to fundamental limits. Sometimes the LLM's reasoning was just faulty, and it kept trying a bad player. Other times, errors would build up, it would make a mistake, analyze the result incorrectly, and that incorrect analysis would lead it to repeat the mistake.
And memory could play a part too.
Definitely. Despite the vector database, it could still effectively forget it had already tried something that failed and just try it again. There wasn't that higher level sense check to break it out of the loop.
Okay, so cost and looping. What about just general reliability and performance? Was it actually good at completing complex tasks?
It was inconsistent. Remember, it was labeled an experiment for a reason. Like all LLMs, it could hallucinate, confidently state things that were just plain wrong.
Right.
And in an autonomous system, that's way more dangerous because it might then take actions based on those false facts.
Yeah.
Many users found it just struggled to finish complex real-world business tasks reliably. It would get lost, go off track, or fail silently.
And the security thing you mentioned with coding, that applied more broadly too.
Absolutely. Giving any program autonomous access to the internet, your local files, and the ability to run code is inherently risky. It could leak data, delete files by accident, or even be tricked by a malicious website into running harmful commands.
So the sandbox wasn't just for coding, it was essential for any use.
Pretty much, yes. Running it in Docker or a VM was strongly advised to limit the potential damage if things went wrong.
So when you put it all together, the cost, the looping, the unreliability, the security risks, it sounds like they're all kind of connected, symptoms of the same underlying issue.
I think that's exactly right. They all point back to the fact that this isn't true. General intelligence, it's not really learning in the human sense.
Awesome.
Well, it's expensive because it uses this brute force, token-heavy reasoning for everything, rather than efficient abstraction. It loops because it can't truly learn from failure at a conceptual level and generalize. It's unreliable because it lacks a deep world model or robust self-verification. It's simulating thought, but it misses those key human abilities. abstraction, generalization, learning from experience, not just recalling it.
Okay, that makes a lot of sense.
Mm.
Now, AutoGPT wasn't the only game in town, right? There were other agent projects popping up around the same time. How did it compare?
Right. It was part of a first wave. AutoGPT was probably the most powerful and flexible, especially with its deep system access and being open source, meaning people could really tinker with it. But it was also the hardest to get started with.
What were some of the others? I remember Agent GPT,
Yeah, Agent GPT was kind of the user-friendly, web-based one. You could try it out in your browser, no complex setup, much more accessible.
but less powerful.
Generally, yes, less direct system integration. It felt more geared towards workflows where a human was still quite involved, maybe guiding it more.
And Baby AGI.
Baby AGI was interesting. It was very minimalist, really focused on the core task management loop. Creating tasks, prioritizing them, executing one. It was great for understanding the basic concept of how these agents worked because its code was simpler, but maybe less focused on accomplishing complex real-world jobs compared to AutoGPT. Each had its own flavor.
So it feels like that initial, maybe slightly chaotic explosion of hype around these general autonomous agents has calmed down. Where are things heading now?
We're definitely seeing a shift towards, let's say, more practical, controlled approaches. Cloud platforms, for instance, where the environment is managed, costs are maybe more predictable, and the interface is often low-code, like the AutoGPT platform itself evolved into.
More controlled environments. Okay. What else?
Specialization. Instead of trying to build one agent that can do everything, we're seeing more focus on agents designed for specific industries or tasks. Think like a legal GPT trained specifically on legal documents and reasoning, or agents purely for financial analysis.
Ah, so domain-specific agents might be more reliable.
That's the idea. By narrowing the focus, you can potentially train them better, constrain their actions, and get more dependable results for that specific area.
So less of a single super agent and
Mhm.
more like a team of specialists.
Exactly. That's a big area of research now. Multi-agent collaboration. You might have a manager agent that breaks down a problem and delegates pieces to other specialized agents. Maybe one for research, one for coding, one for writing the final report.
Interesting, like building an AI project team.
Precisely. The hope is that by combining specialized strengths, you get a more robust and capable overall system.
And underlying all of this, I guess progress still depends heavily on the LLMs themselves getting better.
Oh, absolutely. It's fundamentally linked. Better LLMs, ones with much larger context windows, so they remember more.
Yeah.
Better reasoning abilities, more efficiency, so those API calls aren't so expensive. All of that will directly lead to more capable and affordable agents.
And memory. Is vector search the final answer there?
It's a good step, but probably not the final answer. Developing more sophisticated long-term memory, mechanisms for genuine learning and adaptation beyond just retrieving similar past data points, that's still a huge and vital area of research needed to unlock the next level of autonomy.
Okay, so wrapping this up. AutoGPT was clearly a landmark moment, wasn't it? It showed that autonomous task execution was possible, stringing together LLM reasoning, this recursive planning, and external memory. It really did shift the perspective from just talking AI to goal-driven AI.
Without a doubt, it captured the imagination. But, just as importantly, it starkly highlighted that huge gap between a cool proof of concept and something you can actually rely on day to day. The costs, the looping, the unreliability. It showed that pure, unguided autonomy just wasn't ready for prime time, at least not yet commercially.
So thinking about this deep dive, what's the final takeaway for you, our listener?
Yeah.
As things move forward, maybe the immediate value isn't in AI completely replacing us. Perhaps it's more about augmentation. Could the real future of productivity, at least in the near term, be less about AI working totally alone and more about having these specialized AI teammates?
AI teammates.
Yeah, AI teammates that handle the really repetitive, time-consuming parts of your job, the grunt work, freeing you up for the stuff that needs creativity, strategy, human judgment, nuance. So the question to ponder might be, what specific part of your workflow could benefit from a smart, automated assistant, an AI agent where you're still in the loop, providing the direction and the final sign-off?